Hello, AP Physics 1. It's Mr. Ng with Giancoli, page 39, number 18. This is another kinematics question. Let's hop right into it. So here, at highway speeds, a particular automobile is capable of an acceleration of around 1.6 meters per second squared. At this rate, how long does it take to accelerate from 80 kilometers an hour to 110 kilometers an hour? So I think the first step is to identify the variable. So let's do VVATX. V initial and V final. So let's poke around. I got 1.6 meters per second squared. That's obviously an acceleration because of the unit, right? Meters per second squared, right? And then I got a initial and final velocity, right? Kilometers per hour, right? So here, this is, let's see, from 80 kilometers an hour to 110 kilometers an hour. Fine. And how long does it take? So we need to know the time, and we don't really care about the x. Before we do too much, it's unfortunate that we don't have matching units. This is in meters and this is in kilometers. So let's take a moment to do our unit conversion. So unit conversion first, right? So let's do 80 kilometers for every hour. So to get out of hours, I got to do catty corner. So 1 hour is 60 minutes. All right. And then let's get rid of that. So 1 minute is 60 seconds. All right. Notice how I set it up so the units cancel, where hours will cancel. So now I'm in seconds. That's what I want because I want to get into meters per second. And here, let's get out of kilometers. 1 kilometer is equal to 1,000 meters. So everything on top multiplies, everything on the bottom divides. Make sure that you do divide to do these 260s, or you put these in parentheses. Whichever the case, if you do all that work, you should get around 22.22 meters per second. So I'm going to say or 22.22 meters per second. I went ahead and did the math again for our final velocity. So our final velocity became 30.56 meters per second. Okay, so step 1 done. I filled in my variables. All right, we got some fancy ones I needed to convert. Step 2, I gotta find the right equation. So here I have my velocities and acceleration and a time. So I got my velocities and acceleration and a time. I think I gotta use u. So this thing says that v final is equal to v initial plus an acceleration times time. And we want to solve for time, so let's rearrange this equation a little. That means vf minus v initial is equal to a over t, and then divide both sides by a. That means t is equal to vf minus v initial divided by a. Seems easy enough. I could just plug that in. T is equal to v final, which is 30.56 meters per second, minus v initial. V initial is 22.22 meters per second. And I'm going to divide all that by our acceleration. In this case, it's 1.6 meters per second squared. Notice the meters will all cancel. And most of the seconds will cancel, but this is squared, so there's going to be a second left, which is great because we're solving for time. Oftentimes, when you put in the units and the units cancel, you could check to see if you're doing the work right. I'm going to end up in seconds. I want a time anyways. I know I'm on the right track. So if I do all that math, my time becomes 5.21 seconds, and that is my answer. Again, step 1, fill in my variables. Maybe do some conversions. Step 2, pick the right equation. I picked this one because it's got two v's, both v's, and acceleration and a time, which is what I got. And then I plugged in, right, which I did right here actually. I rearranged the equation, I plugged in and I solved. Good. Thank you very much for watching.